Good day everyone. So today I'm going to show you and explain the layers of the sun. To begin with the phenomenon sunspots. Sunspots are areas where the magnetic field is about 2,500 times stronger than Earth's, much higher than anywhere else on the sun. Because of the strong magnetic field, the magnetic pressure increases while the surrounding atmospheric pressure decreases. So next is the solar prominence. Solar prominence is a dense cloud of incandescent ionized gas projecting from the sun's chromosphere into the corona. Prominences sometimes extend hundreds of thousands of kilometers above the sun's chromosphere. Their causes are uncertain but probably involve magnetic forces. Now let's move forward. Let's start with the outer layer, corona. So there are four outer layers of the sun, and the corona is the outermost one. It starts about 1,300 miles above the photosphere, and its temperature is measured to be around 900,000 degrees Fahrenheit. It is possible to see the corona with the naked eye, but there is an exception. We are able to see it during a solar eclipse or by using a special device called the coronagraph. There is no upper limit to the corona. Followed by the photosphere. So basically the photosphere is the last innermost layer of the outer layers of the sun. We are able to observe this layer directly, and its temperatures vary between 11,000 and 6,700 degrees Fahrenheit. The majority of this layer is covered by granulation, which is caused by bubbling gases and sunspots from magnetic field. And now let's move on the inner layer. The first one is the convective zone. There are three inner layers of the sun, and the convection zone is the outermost one. It completely surrounds the next layer, the radiative zone. In this layer, all of the hot material found near the center of the sun rises, cools down, and drops back into radiative zone to get more heat. This is the movement that creates sunspots and solar flares. This layer marks the border of what we usually refer to as the sun. Next is the radiative zone. The radiative zone is the second inner layer of the sun. It sits outside the core, and it holds its extremely high temperature. The zone itself has a temperature of around 7 million degrees Fahrenheit. This layer serves as passage for all the energy that is released by the core. Photons travel through the radiative zone, and they can travel through long ranges of space. So, it takes almost 50 million years for a photon to travel through this layer of the sun. Last is the core. Finally, we have the core as the innermost layer of the sun. The core is plasma, but its movement extremely similar to that gas. The temperature of the core of the sun is around 27 million degrees Fahrenheit. In this case, nuclear reactions in the core, nuclear reactions occur that create helium from hydrogen atoms. This releases huge amounts of energy, and it starts to move outwards, towards the outer layers. This energy eventually becomes the light and heat we receive on Earth. For the summary and some facts.